Today we're gonna take a look on this old NVIDIA Tesla K20c. Our goal today is to place the thermal paste and get access to the EEPROM under this cooler to flash another VBIOS on it, because this Tesla K20c is restricted to only run CUDA and OpenCL code, and we want to open it for 3D APIs like DirectX or OpenGL. Unfortunately, we can't do this through NVFlash, so we have to use a hardware flasher like this and access the EEPROM with it and flash another VBIOS on it, because otherwise we cannot, or in software we cannot flash another VBIOS. So the first step is to unscrew it and open it. So we finished our job, and yeah, you can see the thermal paste is crusty. It probably haven't been replaced ever since. So yeah, it was not a bad idea to open it, but I have to look which of these little chips is the EEPROM. Well, it seems like that's this one here. So this chip here, that's the EEPROM, and that's the thing that we have to flash. So maybe I have to make sure that it have a good contact, because otherwise it can get corrupted during writing operations. So here are we. I successfully deassembled the cooler and already dumped the BIOS with this hardware flasher. And as you can see here, it should be fine, the dump, because I can edit this in the Kepler BIOS tweaker. But that's just for safety measures, so if anything goes wrong we can just flash the original BIOS on it. But we need a custom BIOS, or we will make a custom BIOS, but first we need NVIDIA Tesla K20m BIOS, VBIOS from techpowerup. I actually found a better solution than just flushing the Tesla K20m BIOS, because as I already said, after flashing this BIOS you get a broken fan control, so you have to buy an adapter or something like that, or cool it with other tricks. But I found a modified GTX Titan, so of the original Titan, and this BIOS works. I don't know who modified this, but you can find it on techpowerup. I will post a link to the description. So I recommend to use this BIOS, but the steps that I will explain After this are the same, so you can also just modify the clocks as you want. But benefits are that you get access to the GeForce drivers. So if you want to game, you get to a certain extent better drivers or better driver optimizations for gaming or for games. Well, not newer ones because the driver support ended, but if you want to play older games, you can get a few percentage more frames maybe with these drivers. But I don't know what is the CUDA performance, if it is worse than the Tesla driver. I haven't done any benchmarks, but I guess it should be pretty much the same. So all in all, we resolved our biggest issue of the original Tesla K20m VBIOS solution. With the GTX Titan VBIOS we get a functional fan control and of course all other advantages of this mod. So we got functional 3D API support and everything else should be the same. So let's continue with the video. This BIOS, or the link of the BIOS, is from another video. I will place a link in the description to the channel or to the video. And you need this here because the K20M is like the K20c equipped with 5 GB of GDDR5 memory, but passively cooled. And this card is basically the same silicon, just with, or the same silicon, yeah, but also the same hardware on the card, because it's the same card just with another VBIOS that allows you to run 3D APIs. And you need to download it, and we will also tweak it to reach higher clocks. So that's this BIOS here, and you can increase the memory clock, but I'm not sure if well, 10 to 11 year old memory is 100% stable at higher clock speed, so I won't do that. But I will increase it to 176. Do that too to these values here. You can don't change anything in voltage and power table, or you can if you want to, but you can leave the settings as they are, and increase it here too. And that should be it. Then you can save the BIOS, so to be flashed .rom, and after that you can load it into this program and flash it again on the card. I cannot film this because my clamp here isn't the best one. It was expensive, but it's already too rubbish to function properly because it doesn't get enough pressure on the chip, so I have to hold it and I cannot film it when I'm doing it. But you just have to flash it on this chip here. Then yeah, of course I already cleaned the die and the cooler. Use new thermal paste. If you want, use new thermal pads as well. I will flash the BIOS, then assemble the card again and place it into my server. And after I have done that, we will install Proxmox on the server and open a VM and pass through this GPU to the VM. And after that, we will see if the GPU will work correctly or if not. I finally achieved to get a clamp on the chip, so I haven't held it like a monkey. You basically then just erase the IC. I already done that, and after that you open the BIOS file and flash it or program the IC. And then again, as I said, you just replace the GPU if you want to replace the thermal pad, and after that you're basically done with tinkering with the hardware, and then you have just to do some software things. So after we successfully flashed our card, we have to do some things in software. We will start with the operating system. In my case, that's Proxmox. So you have to type in your Proxmox IP address with the, in my case, default port 8006. Then you have to log in with your credentials. I already did the things that I will show you, but maybe you want to do the same. I will put a link in the description that will explain it in a detailed way, but just for your information, what I have done in Proxmox. So I basically just created a new VM with Windows 10 on it. You can do Windows 11, but you have to think with like a virtual TPM chip and things like that. So I just used Windows 10. It's a little bit cringe to use Windows instead of Linux, but for gaming it's still the better operating system because things like anti-cheat won't run sometimes on Linux. Hopefully that will change, but to this point Windows is the better option for that. So you just create a VM and give the hardware you want to. So I gave it 8 virtual CPUs. I don't know how the scheduling really works, if the VM gets 8 real cores, because this is a 12-core CPU, as you can see with hyperthreading or SMT. And I don't know how the scheduling works, if it gets 8 real CPUs, if they are free, or I don't know if some workloads can be in 2 threads, and that can efficiently run on 2 threads, in which one core is a physical core and the other one is a logical core through SMT. I don't know, but that isn't important here. And after that, you have to enable PCI pass-through, or especially this IOMMU, so IO Memory Management Unit, to pass through PCIe devices. I guess your Intel CPU need Intel VTD, so I guess that is enabled at the 3000 generation, so 3rd generation of Intel CPUs, like the i7 3770, and you have to enable it in the BIOS because the default is off. After that, you have to do some things in the grub configuration. So I can show you. You can go into the shell through SSH or directly physical on a server, or through this through the Proxmox interface, and you have to edit this file. I use Nano, I'm sorry for that, because Vim is too complicated. So it's basically in this path here as described here. I cannot... here. So you have to add Intel underscore IOMMU equals on. And I already did that, like I said. And after that, you have to update the grub. I won't do that because I already did. But after that, you have maybe to do these things explained after that, but mine work just with this here. And after that, you go to your VM. Then you go to hardware and add, then PCI device and raw device. And here you can select your GPU. In my case, it's the GK110, so it's named like the graphics core, and in the brackets GeForce GTX Titan, because of our BIOS flash. The card thinks it's a GTX Titan instead of a Tesla K20, because both GPUs have the same chips. And then, also important, you have to activate all functions in PCI Express, but not primary GPU, because if you activate it, it won't work, because this GPU hasn't a video output, and you need one to use Parsec. And if you deactivate it, your VM basically thinks, oh yeah, you pass through the GPU in it, but it has no display, so you cannot display anything because the operating system thinks that there's no cable plugged in. So we have to emulate this in the operating system or in Windows, but that's why we need the virtual VNC GPU still inside the VM. So after that, you can go through. Where is it? Through console, you connect to the VM. In my case, it does not work, but I show you with my Tiger VNC client, because I already deactivated the second display. So we are on my VM, and after that you just install the NVIDIA driver like normal, and the VNC GPU will also be used, but Parsec is clever enough to assign the stream to the GPU, so it's completely hardware accelerated. And after that you have to create a virtual display with USB MIDD, and I will link you a tutorial how to do that, but you have to basically create a virtual display so that you can assign this virtual display to the Parsec, like in a normal use case you would assign there a real monitor, but in this case a virtual monitor. And because of that you can use Parsec, because what I already said is when you don't do this, there's just the VNC display, and that's a low resolution, and it will disappear when you disconnect from VNC. So you have to create one, and you can make it like this, the resolution like you want. In my case, full HD. And that's basically things you have to do. If you use a Tesla K80 or something, you have to do some registry hacks to get it running. But in my case, the PC thinks it's a GTX Titan. So you just install Parsec, and everything should work. So that's the next step we are gonna do. Open Parsec, connect to our PC, and we are here. It's fully hardware accelerated. You can see by the smoothness, and if you look in the task manager, WDDM is activated because we see our GPU here, and video encoding is working, and it is doing some things, so it's basically this video stream. We can open GPU-Z for this to show you that the BIOS flash has worked. And with this custom BIOS, it thinks it's a GTX Titan, so the fan control works. It's not the same as the from the Tesla, because the Tesla one's more aggressive. So this GPU will run a lot hotter. I guess the standard Tesla K20c BIOS let the card run at a maximum of 65 degrees, so it gets really loud. And this is like the normal GTX Titan fan curve, so it gets like to 80 degrees with the, I don't know how it's called, with this boost, I don't know how it is called again, from NVIDIA. But as you can see, it's a GTX Titan. We got Vulkan support, CUDA and OpenCL of course too, but as you can see, we have DirectX support. We can utilize it. and initialize it. As expected, so the BIOS flash worked. And a nice bonus to this card is that we now unlocked PCIe X16 3.0. Or it reports it, because the K20c only supports PCIe 2.0. But I don't know, I haven't done any tests if it is really working, but it's a nice bonus for machine learning tasks. But for gaming, it isn't important. But that's basically the card. It works, and now you can play games, basically. So I will launch 3D Mark for this purpose. And you can see it's near native performance. Well, of course, the GTX Titan, the first one, is 10 years old, and the architecture 11 years old, or even later. So it isn't the best gaming architecture or fastest card on the planet, but I just wanted to show you if you're on a budget, and I don't know why, but you got hands on very cheap Tesla K20cs, because they were sold in like workstations as the HP Z420. You just basically need a hardware flasher from AliExpress for €10. Or I don't know, in the US, $10, $8. And then you can flash basically your cheapo K20c to a cut down Titan, because if we open GPU-Z again, you can see it basically or logically didn't unlock any shader units or CUDA cores. So we got the same amount, 2,496 unified shaders. So we didn't get more shader CUDA cores unlocked, because I think the original Titan had, 100, 200 CUDA cores more unlocked, and the Titan Black or GTX 780 Ti, so the fully unlocked GK110, got 2,880 or something like that. And it's a difference. I'm interested in it. I can look it up. How many TI techpowerup? How many CUDA cores are activated? 2,880, as I said. And you can see we got more VRAM, basically, because of the 5 gigabytes. That's the same where the Titan got 1 gigabyte more. But still, in some places, you maybe will get a K20c very, very cheap. And yeah, the base clock is a little bit lower, but you can overclock this chip fairly bit. And if you look, GK110B, which card? That's the GK110B. I don't know if the original Titan used that. That's the Titan Black. It got the same amounts of CUDA cores. Now then we have to look at the GK110. And that's the K20c with a cut down version, and the original Titan, got 2,688 shader units and 224 TMUs. So it's a little bit cut down, the Tesla K20c actually. But, well, this old architecture, I don't know how it scales with more CUDA cores, but I guess you can just increase the core clock, and I don't know if you can. Maybe you have to look if you can increase the voltage, but then you can overclock it a fair bit, because what I remembered is that Kepler was really good at overclocking, especially GK110 and the 780 Ti and Titan, if it was cool or cooled well. And so we basically reached all of our goals. We enabled 3D APIs. We still have the fast FP64 performance, because the Titan and the K20c have both 1/3 of the FP32 performance at FP64. Here, that's the K20c. The Titan has the same advantage. Then, well, we got UEFI support, PCIe Express 3.0 support, and newer drivers, so more gaming-oriented drivers, but that basically isn't important for this card because I don't want to game with it. I just wanted to have some 3D acceleration for like things as Waifu 2X and like this, because you need sometimes just some workloads on Vulkan or DirectX, so you have to run these. Yeah, I know you can see here many games, but that's for another project. I wanted to test how game streaming, local game streaming works with latency. But as you can see, everything works. So we just unlocked like a fully working GTX Titan with less CUDA cores and a gigabytes less of VRAM. But still, that's very funny that it will work, or that it worked. And yeah, that's basically it. So I want to show you the 3D Mark results. I don't know if it is saved here. That's not cool. Okay, so we have to do it again. No problem. I got the advanced edition. So the old Firestrike without the demo, but with MSI Afterburner overlay. I will stop this download. Don't know, we want to have every little bit of performance we can have. Well, we are using Windows, so that isn't achievable. But yeah. So without the demo, we don't need it. MSI Afterburner, everything on stock. So because we got a Titan BIOS, it clocks a little bit higher, as you saw in GPU-Z. We also get Turbo Boost in the WDDM mode. So I will not overclock it because when it runs cool, it would automatically overclock itself. So I won't do anything. Power limit you can just increase to 6%. That's well, it doesn't change anything because it does not run into the power limit. Maybe temp limit, but for this short test, I don't think so. So we will run it. The old Firestrike test, I know it's pretty old. I guess 10 years old. 2013 or 2012 it was released. I know that I ran some tests on my old R9290, so card that's roughly has roughly the same performance as this card, and I guess I bought it 2014, and I remember that this test was fairly new, but I don't know. But we won't do the time spy benchmarks because it's DirectX 12. This card or Kepler supports it, but only with feature level 11. So we just use the old DirectX 11 benchmark, and yeah, we'll see the results. But as I already said, that's close to native performance because we pass through the GPU directly to the VM, so there shouldn't be high overhead. You can see Kepler isn't that efficient to today's standards. It uses 200 watts, and yeah, it has the performance of, I don't know, under entry level card from NVIDIA, AMD, or Intel. So the test finished. Yeah, I did another test and I got 300 points more, but I don't know if I overclocked the GPU in it. But if you want to compare the results online, you will see that it's basically not much faster than a laptop for business, as this device here states. So yeah, it is 10 years old. It isn't the fastest GPU or CPU combo that you can imagine. Like, these are hypervised Ivy Bridge CPUs basically, and this is a Kepler GPU, so don't expect good or extraordinary performance in 2023. You see, it's a third of a budget gaming PC with an RX 70600 or 13 Gen i3. Yeah, it's old, the hardware, but still, I don't know. In some countries, you maybe have to use these because, I don't know, your market is fucked. Or I don't know if you're in some countries, if you even can get like new hardware, I don't know. So maybe old Tesla GPUs are your way to go, especially the K20c, because it already has a fan. So you just need a cheap integrated CPU and call it a day. I don't know. But yeah, as you can see, it's pretty slow. I don't know if I have all results of... there can you see it. I already did 2 days ago. But I don't know if I have old reviews now, just for my RX 64. RX Vega 64. No. I don't have any. But maybe from Firestrike Extreme. So, okay. So, wait. Yes, here. So, in comparison to a Ryzen 5 3600 and then RX 590, you see, this combo was much faster, and this hardware was much cheaper to buy than this back in the day. And yeah, you see that the CPU is twice as fast, and yeah, the GPU too. Yeah, not twice as fast, but as you can see, 66%. At the GPU, yeah. You see, it's old. I guess the Kepler support ended in 2021 for the real gaming optimization. So you cannot use it for anything useful other than some compute tasks or machine learning, and even these tasks, due to the fact of the CUDA compatibility of 3.5, isn't really good supported anymore. So it's basically trash. But it was funny to flash it to an consumer grade card, or not consumer but prosumer grade card, and activated all features that easily, because because you can't do this on newer GPUs. It's locked. I guess beginning with Maxwell it was nearly impossible. But I read that even at these with this K20s you need to solder some resistors to let the card think it's a Titan. But in this case, I don't know who modified this BIOS at techpowerup. It's working like a charm without. Maybe because it's a K20c or not a K20X. I don't know. But yeah, it's working. We got the same features as before, just with some added bonuses. And yeah, that's it. that's what I wanted to show you. That it is that easily to tinker with your hardware, so do that. Don't use Windows other than for gaming. Use Linux. No, I'm kidding. Use what you are the most productive. And yeah, thank you for watching this video, and see you at the next time.